Good evening, everyone. Welcome to 94th video, I think, on misconceptions in physics. Well, my name is Ratankar. I teach physics in an international school in Bangalore. For those who are new to these videos, this is an introduction about me. My passion is to teach physics. I have around 2 decades of experience in teaching physics. And the result of the videos that you see here is I have an hobby of correcting the papers. And while I grade the papers, I just look at those problems which most of the students make a mistake and keep it aside. And these problems, I find that the student get confused because of similar concepts. And the result is I have taken such problems. I looked at the student response, what he or she has done in an exam, and what it has to be, and why this confusion is arised. And I try to break this, okay, or resolve this problem. So that's the result of this. I have a collection of more than 300, 350 problems. So I thought, okay, continuously for a year, let me continue doing this. So I'm nearing to something like 94, 95th video. And I do have a website, okay, wherein I have put across all these videos. So currently, so the website name is ratankar.com. You can visit this website and you can get to know about what are all the videos I've updated it so far. And a few of them still yet to be updated. I'll be shortly doing it. So nearly 94 videos have been done so far, and the rest of them I'll be doing it shortly. So currently the chapter that we are looking at is the chapter on rotation. Rotation is a topic which is very difficult for those students who are learning or who are attempting the exams like JEE mains or advanced. So basically it has been focused only for these students, of course, but students who have taken up IGCSE, CAS and A level examinations, they also do have rotation. And students who have taken IBDP, especially those who have opted for the elective like engineering physics, they have this option. So for them also, these kinds of videos would be very useful. And it is always said that if you excel in rotation, that means you are very good in all the other topics of mechanics. That's why rotation is the last chapter in mechanics. Okay, so much introduction. So let me continue with this. So this is my 19th video in the chapter on rotation. So still there are some more to come. Let us look at it one by one. So a light rod of length 1 meter. 1 meter is pivoted at its center. Is pivoted at its center. And two masses 2m and m are hung from the ends as shown in the figure. 2m is hung here and m is hung here. This length of this rod is 1 meter. 1 meter. Okay. The system rotates with an angular velocity, angular acceleration of alpha 1. Now this is rotating. How will it rotate? So let us say it will rotate like this because this 2m is much larger. The mass of the rod is also m kg. Mass of the rod is also m kg. Then how will the acceleration differ? Okay, so initially what does it say? It says a light rod. When I say it's a light rod, that means it doesn't have any mass. So as a result of it, okay, so because of the gravity, so it rotates with an angular acceleration alpha. Okay, that's what. Now, what is the student response? Student response says that since this rod is not having any weight. Okay, so I can now write 2m minus m into g into 1 by 4. Why 1 by 4? It's nothing but, what is this now? This is nothing but your torque. Okay, what does torque tells you? Torque tells you that this is F into R. F into R. F into R should now be equal to, I think I made a mistake here. Okay, let me take it out. 2F, what is force here? Force is nothing but 2m. So this will now produce a torque like this. This will produce a torque like this. But this torque is much larger. Why is it larger? The reason is because torque is given by F into R. If you remember, F into R. F into R. So the anti-clockwise torque here is given by 2m into R. What is that R? R is nothing but it's at the center. So this should be 1 by 2. Oh, I made a mistake over there. Let me show you. This is 1 by 2 here. Okay, 1 by 2m into half is nothing but, I'll write this as anti-clockwise torque. Okay, ACK, anti-clockwise torque. And then if you write the clockwise torque, this should now be equal to m into half. M into half. M into half. Just give me a moment. Let me do it once again. Okay. So the anti-clockwise torque is 2m into half, and the clockwise torque is m into half. So this is a vector which goes like this. This is a vector which goes like this. So this vector is larger than this vector, and hence the rod will now rotate like this. So this the net torque is nothing but equal to 2m into half minus m into half, which should now be equal to m into half, which will be m by 2. Okay, so this is what I should get. See, this is once again, there's a force here. So I should write this is the mg force, right? Mg into horse. This should now be equal to, what is this now? This is moment of inertia. Moment of inertia of what? Moment of inertia of this particle is nothing but 2m into r square, which is 1 by 4, plus m into r square into alpha. So making use of this, now what do I get here? I should write this as mg by 2 is equal to 3m into alpha, 2m plus m, 3m into alpha divided by 4. This should now be equal to this m, and this m goes away. And thus you are now able to write this as alpha is equal to 2g divided by 3. 2g divided by 3. Let me rewrite it once again. 2g divided by 3. Am I right? This is 2g divided by 3. Correct. 2g by 3. So this is what we get over here. Now, this is not the question. The question is, if I make the mass of the rod equal to m kg, that means instead of taking a light rod, if I take a mass m here, then what will be its effect on alpha? Now, if you look at this, this does not have any effect. The reason is because there's no dependence on m here. So as a result of it, okay, it will not have any effect. This is what the student writes. But there's a misconception here. The reason is because this m will definitely have an effect. Let us see why is this shown like this, or what is the reason here. The reason why the student considers this as this is possible, the reason is because he takes into account that the mass of this rod will act here, and this will not introduce any torque. Okay, that's what is the problem here. But usually, when we write here, of course, I agree that this mass will not introduce any torque. Okay, now we need to ask what is the system here. The system here, okay, if I consider this mass here, then this system should be this mass plus this mass plus this mass. In other words, if I consider the whole system, the moment of inertia will not be like this, but the moment of inertia of the rod should also be considered, right? See how easy it is. You have to understand like this, how easy it is to rotate a lighter rod, and how difficult it is to rotate, okay, a massive rod. Definitely, when the rod becomes massive, it becomes more difficult for you to rotate. As a result of it, the moment of inertia contribution comes here. Okay, we should not ignore the moment of inertia due to the rod, which means that when you push an object to make it rotate, definitely you need to apply a larger force, because the inertia of the object will come into existence. Okay, so I hope you understood the misconception. Now let us look at, okay, how to resolve this. Okay. Now the correct solution is, let me redo it once again. You have a rod of length 1 meter. You are adding 2m here. You are adding m here. This is the center. This also has a mass m. The length of it is seen to be 1 meter. 1 meter. So the distance between these two ends is half meter. Distance between these two is also seen to be half meter. Now what do? I will say 2mg is the force acting downwards. mg is the force acting here. I'll add one object here. I'll add another object here. Okay. The torque here is nothing but, the net torque here is nothing but 2mg into r into half minus mg into half, which should now be equal to mg into half. Okay. And then what else we have? Moment of inertia. Now, moment of inertia of the system, the entire system, should now be, this is a discrete particle. So this should now become 2mg into r square, which should be 1 by 4, right? M into r square. So not mg, it should only have m here. 2m into half r square. Plus, now what is the moment of inertia of this object? It should be m multiplied by 1 by 4. Now, don't consider that this is negative moment of inertia, because you know, this is, though the negative, the distance is negative over here, it becomes r square here. So it becomes 1 by 4 over here, plus m into 1 by 4. Plus, what is the moment of inertia of the rod of mass m pivoted at the center? This is nothing but m L square divided by 12. Now, what is L here? L is 1 meter. So, therefore, now I will write this as 2m into 1 by 4 plus m into 1 by 4 plus m into 1 by 4 plus m divided by 12. I put n equal to 1 meter. L equal to 1 meter. I got this. Now, let us calculate the whole thing. So, this would now become 2m into 1 by 4 plus 3m into 1 by 4 becomes 3m by 4. 3m by 4 plus m by 12. Now, let us calculate what is this. I'll take 12 as a LCM. 4 3s are 12, 3 3s are 9. 9 plus 1 into m, which should now be equal to 10m by 12, which is equal to 5m by 6. Now, what should I do? We know that tau net is equal to I times alpha. What is he asking? How will the angular acceleration differ? Okay, let me call this I alpha 2. Okay, so therefore, now what will we have here? Tau net is nothing but what? mg divided by 2, which should now be equal to 5m divided by 6 into alpha 2. What is alpha 2? I do not know. I should write this like this. So 2 1s are, 2 3s are, and this m and this m goes away. So in other words, alpha 2 should now be equal to 3g divided by 5. Okay. Without the mass of the rod was the answer which the student calculated earlier. What was the value? Let us go back to my previous slide. So the value that we got for alpha was seen to be 2g by 3. Okay, that was without the mass of the rod. Okay, now with the mass of the rod, this is what you get. So alpha 1 is equal to 2g by 3. Now what do you understand from here? Now this is, you see, if I put g equal to 10 over here, you get the answer here as 40 by 3. Okay, sorry, 20 by 3. 20 by 3. My bad. Okay. Now here, if I do this, now what will this become? 3 into 10 divided by 5 will be 30 by 5. And if I want to have, okay, so, right, 30 by 5, which is equal to 6 meter per second square. 6 meter per second square. Here, what will become? This will become 3, 6 are 18, right? 6.66 meter per second square. Okay. Are we doing it correctly? 3g by 5, yeah. Okay, so thus you see there's a difference in the moment of inertia that we observe. If you like this video, do share and subscribe to my channel for more updates. Thank you, friends.